Um, Can we start the clock? Just be cautious of time. Hi, everyone. My name is Tsahi Duek. I'm a principal solutions architect for containers at AWS. I mainly work around containers technology, containers use cases with customers across EMEA. Along with me, I have Dima.
Hi, everyone. Thanks for joining. My name is Dima Breydo. I'm Principal Solutions Architect with Amazon Web Services. I'm based out of Tel Aviv, and I work with Israeli startups.
And as you can guess by the name of the session, we're going to talk about multi-cluster management, using infrastructure as code blueprints, and GitOps for accelerated deployment. And our agenda for today is going to cover four aspects or 4 talking points. The first part is going to be the challenges you might face, what we saw customers facing when they try to operate in a multi-cluster manner. Then we're going to talk about infrastructure as code composition, why they're important, and how you can leverage them to solve one part of the problem or one part of the challenge. Immediately going on to GitOps for our deployment, for application deployment, and how you can connect both of them together, the infrastructure as code part and the GitOps part, to create a sustainable and repeatable solution for multi-cluster management. And we wrap it up with Dima showing us a demo, a live demo on a solution we've built around a framework we've created at AWS. But the principles, one thing I want to mention is that the principles that we've used to create this framework and to create this solution, you can apply them to any other management system. So let's start. And the journey that we see is usually customers trying to or choosing to use Kubernetes. And the next question is usually, now what? What I have to do to run Kubernetes in production? And I hope you do. I do. The first point is to go to documentation. And documentation is really, really important, where you get the features, the benefits of Kubernetes. I'm not here to talk about that. But you suddenly realize, you see how many icons you have here on the display. It's quite complex. You have to manage, there's a lot of moving parts, and you have to orchestrate all of them. Now, this is where you have to maintain proper lifecycle management for your control plane and data plane. Control plane, we leave it aside, as in AWS we have Amazon EKS as a managed service, and we have Rancher here that can operate in a lot of multi-cloud environments or even on-premise. But we take it to the next step, where you have to operate data plane, node groups. And node groups is usually the most common way of managing infrastructure for your control plane. It's basically a set of nodes that have the same characteristics that can apply to your application running as pods. One thing I want to mention is that we developed a new open source project called Carpenter. It's not very new right now, like it's been out there for more than a year. It quite evolved. We even open it up for other vendors to be able to implement their own use of Carpenter. And the difference between the two of them is that Carpenter uses just-in-time provisioning mechanism, so you don't have to know in advance the node group or the characteristics of the workload. You can just let Carpenter decide based on the specification you put in your application. And as you can see here, we have many different types of instance types. Now, this is not enough. This is just a bare cluster with nothing on it. To be able to run applications, we need to run system-wide operations, system-wide applications that provide general capabilities. One of them can be observability, DNS, routing, all these kind of things. And as you can see from the CNCF landscape, this is probably the most overused deck in the history. There's a lot of tooling out there. And you need to invest, and you need to have a proper lifecycle management for all of these add-ons as you can see them here. Now, as a next step, I've been to another talk of Dario where it's talking about multi-tenancy. And multi-tenancy is a thing. You have different applications, different pods running in your cluster, but you want to make sure you have a separation of control between them. And usually you achieve this in the form of namespaces. Within the namespace, you define a service account for applications, so they have a defined, fine-grained permissions for those applications. You can even define service quota, limit ranges, or any that kind of limitation around your application in these namespaces. And the last thing you should do, you should invest on, or you should configure the access control for external team to be able to access the namespace and only their namespace. And as a last step, to wrap it up all, we need to invest in the multi-cluster. This is what we're here for. We need to be able to operate our cluster and replicate it consistently across multiple environments with the same set of configuration. We can tweak it, we can do some environment-specific configuration, but we need to be able to replicate this easily across dev, test, production, or any kind of environment you have. We even need to consider, if you're running on AWS, you need to consider a multi-account strategy where those environments might live in different accounts, different regions, different VPCs. And as a last step, we want to have a single pipeline that orchestrates the whole thing together. Now, as a first step towards the solution, this is where infrastructure as code composition come really useful. And why do we need them? This is just an example, sorry for the smaller font, but this is an example from the Terraform documentation page. To be able to provision a cluster, you need to provision the cluster, the data plane, OpenID Connect provider, and you might want the Fargate profile. Now, a composition is a set of high-level abstractions that gather together, or group together, low-level constructs for your application or for your infrastructure. And this is how we call it in AWS CDK, which is our infrastructure as code tooling in AWS. And Terraform, it's been called modules, but the practice is the same. Now, the community already created EKS module. Probably if you're working with Terraform, you know that. If you're working with AWS CDK, we have the AWS CDK module where we group all of this together. But if you remember the first part of the presentation, what we're missing here is we need to define the add-ons. The add-ons are usually being operated or being orchestrated as a Helm releases, and we need to be able to deploy them in our cluster. We talked about multi-tenancy. This is where we need namespace separation for our cluster. We also need RBAC permission for users to be able to authenticate and be able to access to that specific namespace. And again, this is an example of code pipeline. You can apply this to any other pipeline tooling you have. You need to be able to group all of this together to a single pipeline for your infrastructure. The next stop is GitOps. And GitOps is for the application part. We talked up until now, we talked about infrastructure. GitOps is for application. And before talking about GitOps, let's talk about its what we see is that it's very important to set up the definitions of GitOps. This is not mine. This is the CNCF definition or principles of GitOps, which basically mean that in GitOps, there are 4 principles that says that the entire system is expressed declaratively. It's stored in immutable and versioned way in a storage. It can be Git, it can be something else. You have software agent that automatically pull the configuration from the source, and you have those agents are continuously reconcile the state based on the observed state, the desired configuration based on the observed state in the cluster. Again, before talking about the actual implementation of GitOps, we see out there 3 GitOps topologies that we call them. One, the first one is the simplest one, and this is what you'll see in the demo the Dima will show, is a standalone GitOps. Standalone GitOps means that each cluster, in this case it's Argo, you can apply it to Flux as well. Each cluster has a GitOps instance being installed into the cluster, and all of those clusters are pointing into a single or multiple Git repository, doesn't really matter. The benefits of this topology is that you have repeatable and isolated clusters where you can easily replicate the configuration without relying on other cluster configuration. You also have separation of control. If you remember, like there was a lot of hacking or CVEs that been used a single server to be able to access all the infrastructure of the company because it was a CI server or CD server that basically know and had access to all the infrastructure. In this case, you don't have it. Each class is isolated. It can live in a disconnected network from the other. The second one, you might call it centralized management. We like to call it hub and spoke with a push model. Is usually being used by platform teams that want to control and want to have a centralized place of bubbling or pushing up configuration to remote cluster. So this is where we have a centralized GitOps instance being deployed on the central cluster, and it being pushed to all the other clusters that are being part of the system of the network. One thing to keep in mind here is that you have to maintain network connectivity, and you have to also be able to connect the clusters after you've created them using infrastructure as code or any other tooling. We have cross-plane outbound out there. The last step is a mix and match of both. We call it hub and spoke with push and pull. We have GitOps instance in the central cluster. Usually it will be used by the platform teams to be able to push and use and provision and deploy the add-ons to all the remote clusters, where the remote clusters will be able to reconcile per team or per business unit specifics application into the specific cluster. Now, the solution we're going to talk about today, and the demo Dima will show in a minute, is relying on a framework we've created for customers called EKS Blueprints. And basically, it's a wrapping, it's a configuration, everything I've discussed so far together. It's an infrastructure, it uses infrastructure as code for Terraform and CDK. They're quite different and they had quite involvement in time. What we're going to demonstrate today is the CDK part, the AWS CDK part. It's like a monolith framework for creating EKS cluster at scale. It built in best practices into the configuration of the framework. You can integrate it with other tooling in the Kubernetes ecosystem, and you can extend it. So if there's something that's missing, you can either contribute, extend it on your own, or do like a workaround to be able to integrate this with the framework. And what EKS Blueprints is basically a 3-layer foundation. The first layer is the compute capacity and the control plane, whether we're running on BottleRocket, Fargate, whatever data plane options we have out there in AWS. The second part is add-on lifecycle management. You will see how easy it is to be able to deploy add-ons into the cluster and all the replicated clusters. And the last step is what we call teams. The teams is basically a construct that allows you to define multiple application teams that can access to the same cluster. Now, let's dive deep in what application team means. When you define application team using the framework, what we're doing, what we created behind the scene is the creation of a namespace. You can define custom labels, custom annotations. We also put quotas or limit ranges or any other manifest, Kubernetes manifest you need to apply to that specific team or that specific namespace. We create the RBAC permission and the IAM role on the AWS side, so teams can access that specific namespace and assume this role or assume this user. It depends, like in your configuration. And we also have the capability to be able to create the IAM role for service account in case your application need to access external AWS, external to EKS services such as S3, RDS, and ASG in this example. Now, the last thing that we'll show here is how we can leverage the framework to have a pipeline as code to deploy multiple environments. We'll start with the 2 environments, dev and production, with test missing, and 3 application teams that are being deployed in the class. Actually, we have 2 application teams, Dima will onboard one of them. And we'll see how the platform team owns a configuration repository that will be triggered, and the pipeline itself will be declared as code in the blueprint, in the configuration itself, and by just duplicating a few lines of code, you can replicate the same cluster configuration and create another environment. Now, one thing before I hand over to Dima to keep in mind, the solution can be treated in 2 different ways. You can treat it as a centralized management, as you are the platform team and you own the cluster provision, you own the cluster management, and you only give access to application teams to be able to deploy their application in the cluster. Or you can replicate the same solution in case you have a large enterprise, large organization, and you want to have autonomy, you want to have independent for each business unit to be able to deploy their own pipeline and blueprint based on what you've configured, and they can tweak it. They can create additional environment, remove environment. It depends on how they want to do it. So keep in mind you have both options to do it. And in terms of GitOps, what we'll show is how you can easily onboard. This is like using the app of apps pattern of Argo CD, where adding a new application is able to leverage the pre-existed by the blueprint itself, pre-existent namespace, and being able to connect together the repository to the deployment namespace. So from that, I hand over to Dima and the demo gods.
Thank you, Tsahi. So just let me 1 second switch into the Visual Studio. Okay, so as Tsahi mentioned, in the demo, I will start from the initial state that we have already set up, where in this initial state, we have 2 Kubernetes clusters in different environments, development and production. There are 2 application development teams in the beginning. Each of them owns a microservice. And then as part of the demo, I will show how this whole setup has been created, how it's being managed. I will onboard a new application development team into the system. I will also onboard a new microservice for this application development team, and I will add a new environment, a test environment. So there are 5 repositories here that I cloned from GitHub. So let's understand what are those repositories. So the first one, it's called CDK EKS Blueprint Patterns. And this repo, it's a collection of examples and solutions that you can use in order to get started with the EKS blueprints. And some of them are really dive deep, as the one that I'm going to show here. Some of them are good if you want to pick up something and get started with something fast. I will show this repo in a minute. Then we have 3 application repositories, so ignore that they are called starts with ECS demo, ignore this part. But there are 3 applications, so one of them is called, so there is 1 frontend, and there are 2 backends, backend Node.js and backend Crystal. So frontend and Node.js are already deployed, and Crystal is not yet deployed. We will deploy it soon. And those repositories contains all the application runtime, including the Kubernetes manifests that deploy those applications. And the last repo here, it is called EKS Blueprint Workloads repository. And this is a collection of different ways or methods of managing GitOps. We are going to focus on this particular one that is called multi-repo, Argo app of apps, where we have subdirectories for each of our environment, for dev, for prod, and for test. And under each subdirectory, we're actually managing custom resources of Argo CD that point to the 3 application repositories that I just showed you. And so this is an app of app patterns of Argo CD. So we'll touch this part in the second part of the demo. So now let me go here to this repository of the patterns. And I will focus, so as I said, there are multiple use cases that are supported here. So I'm going to focus on the one that Tsahi and me developed. It's called Pipeline Multi-Env GitOps. And as you can see, okay? Okay, so as Tsahi said, EKS Blueprints comes into flavors for CDK and for Terraform. So this demo is using the CDK version. And it's written in TypeScript, which is currently the only language supported by the EKS Blueprints for CDK. So everything starts here from this import, where we import the Blueprints module. And it contains all the constructs that we are going to use here. Then there are some constants definitions. So one of them, for example, is this repository. So the reason I'm using my own user here and not the AWS sample where this repo exists is because I also need to be able to commit into this repository. We'll do it as part of the demo, so this is why I forked it. Then we have some environment variable definitions. Specifically, we define account and region for each of our environments. So we have, in this case, everything is done in single region, but as Tsahi said, each of our environments could have a different region, different account, and this is why it is defined here. Okay, so this is less interesting. Now let's move to the more interesting parts. This happens here within this method that is called build async. So first thing is that we are defining teams. So let's see what does it mean to define a teams. You can see that we are defining teams for each of our environments, for dev, for test, and for prod. Okay, and there are 4 teams. We have core platform team, And we have front-end team, backend Node.js team, and Crystal team, which, as I said, is not yet deployed. Now let's understand what's inside those teams. So, for example, let's look at the application team, a front-end team. So what makes it an application team is that it extends from the application team in the blueprints. And as Tsahi said, application team owns a namespace. So this is where we define this namespace. And all the team members, they will only be able to access this and only this namespace. And we are also defining here a list of users, or in more realistic scenario, these are probably roles, and they will be configured in terms of RBAC, in terms of AWS IAM, to be able to access this namespace. And there are many other things I can pass here as well. For example, depending what does it mean for you to create a team. So maybe it means to apply some additional Kubernetes manifest, so you can supply it from here, or maybe the platform team wants to define resource quotas for this particular team, so this is all could be defined here. And more than that, not only Kubernetes, if, for example, for you, new team means an S3 bucket or some other resource, you could also add additional CDK here, CDK code here, so that it will be created together with the lifecycle of the team creation. So this was the application team. Now let's look at the platform team. So platform team, unlike the application team, it doesn't own any namespace, but instead it owns an administrative permissions into the cluster, and this is what is defined here. So as you can see, we have here the front end, we have here the Node.js, we don't have the Crystal, and this is because I took this file out. So let me bring it here. And let me do a couple of more changes here. So I need to add this export. And I also need to go back here, remove this comment. And now I want to commit and push. So add Crystal team. OK, and this will trigger the pipeline to add this team into all of our clusters. I'm going to show this pipeline in a couple of minutes. So in the meantime, while this happens...
I think you missed the uncomment.
Sorry?
I think you missed the Control Z. The creation of this build team. The function is being called up there, isn't it?
No, it's OK.
Yeah.
OK, so... just 1 second. So let's go back here. So this is the teams. Now, this is less interesting. I will not talk about this. Actually, it is. So this is here we are just checking for existence of some secret in AWS Secrets Manager that is needed for the pipeline to be able to access my GitHub repository. So this token is defined there. And now let's see, these are the interesting parts. OK, so we want to create a blueprint. This blueprint will allow us to create multiple environments from this blueprint. In order to create a blueprint, we need a couple of things. First, we need to create a cluster provider. So here you can see that we are creating a generic cluster provider on the blueprints. Now, there are also other types of providers. For example, we could use AWS Managed Node Group provider, but since here we are using Carpenter, and Carpenter, it's an autoscaler, which doesn't have the notion of node groups at all. It doesn't need any node groups. This is why we are defining the generic cluster provider. Now, we still need to run the Carpenter itself somewhere, and we run it on Fargate, which is our serverless engine supported by EKS. So the Carpenter runs on Fargate, and the rest of the nodes will come from Carpenter that will autoscale them. So this is the generic cluster provider. The next thing is that we are creating add-ons here. So you can see that we are creating a list of 3 add-ons. Okay, we have AWS Load Balancer Controller add-on, which is an ingress controller. We have a secret store add-on. We have a metric server add-on. And this is a list of add-ons. It's common for all of our environments. And now with this, we can create a blueprint. So blueprint, we are using blueprints.eks blueprint.builder. We are passing it a Kubernetes version. We are passing it the cluster provider that I just showed you, and the list of add-ons. Now you can see that we are really passing like literally 0 parameters here, because everything is already configured. All the add-ons with all their defaults and best practices are part of the EKS blueprint solutions. Now, obviously, you can customize here the add-ons if you have like specific configuration that you need to pass here. So whatever the add-on Helm installation values accepts, you can also pass it from here. And this is a blueprint. Now, it's still not an environment. We will need to replicate this blueprint into multiple environments. Before that, some additional add-ons that we are building. So the previous list of add-ons was common for all environments. Now we also have some add-ons that require environment-specific configuration, and this happens here. And so you can see that we are passing 3 more add-ons here: the Carpenter add-on, the Argo CD add-on, which I will show in more details soon, and the Cert Manager add-on. So now we have also environment-specific add-ons. And this is where then we create the pipeline. So what does it mean to create a pipeline? So we pass it, we configure it to this repository so that whatever I push will trigger a run. And there are 2 terms here that are important to understand: stage and wave. So each stage is a separate EKS cluster. So, and I can put stages under the same wave or under different wave. If stages are under the same wave, they will be created in parallel. If I put them under different waves, they will be run sequentially. So there are 3 environments here, or 3 stages: the dev, so you can see how we are creating it. So it's a blueprint, .clone, and then we customize with some environment-specific things. So we pass the teams here, and we pass the additional add-ons. Then we have the test. It's currently commented out. We will remove this comment in a second. And then we have the manual approval step. And then we have the production as part of a different wave. So now let me commit this change as well. And then I will show you the pipeline that was created from this code. So add test environment. Let me push it. Okay, so now let's see the pipeline. So here, the EKS blueprints for CDK is using an AWS service that is called AWS Code Pipeline. And so here, this is the pipeline that was created. You can see that it's running now because I just did a push. So more than that, it actually should run twice now. So we can see that there are 2 runs that are currently in progress because I did 2 commits. The first one was to add the team, and the second one was in order to add this new environment. So now let's see the pipeline. So the first is the source step. This is the webhook to my GitHub repository. Then there is the build step. Then there is this update pipeline step. It's called self-mutate. So this is a self-mutating pipeline. And what it means is that in addition to this pipeline being able to manage all the configuration of all the EKS clusters that I'm managing with this pipeline, it is also able to update its own structure. So whenever I add a new cluster, or remove a cluster, like I did in this case, I added a new cluster, this step will identify the change, it will cancel the current run, it will rebuild the pipeline in the new structure, and it will continue from there. This is exactly what I expect to happen in a couple of minutes. Then this step is not interesting, and these are the actual steps of the environment. So this is my dev environment. Then there is this manual approval step, so you can see that the dev environment is currently running. And then we have the production. So I think, so let me just go back to here and run kubectl get namespaces. So I expect here to still have the only 2 namespaces for the front end and for the Node.js. And as part of this run, so yeah, you can see this is the front end, this is the Node.js. I still don't have the crystal one, but you can believe me that it will be here probably in a couple of minutes. Now, while this is happening, so let's understand what happens from the application perspective. Okay, so I'll go back to the code, and let's understand what was happening with the Argo CD add-on. So as I said, one of the add-ons that we created here was the Argo CD add-on, and this requires some special configuration. So the Argo CD add-on, we are passing it a bootstrap repository, which points to the 5th repository that I was showing to you in the beginning, this one, the EKS Blueprint Workloads repository, to a specific directory, which is environment-specific. And if I open this repository and go to this directory, so it's here. So for example, on the dev, so on the dev, you can see that I have the front end and Node.js, and also here I didn't onboard the crystal yet. So if I open it here, you can see that these are custom resources of Argo CD. a custom resource called application. And the application has a source and a destination. So the source is the repository of, in this case, the Node.js application, so this one, and the destination is the namespace. So it's here, this is the namespace. So if I want to onboard a new one, I actually need to add the same one for Crystal. So I have it here, so let me bring it back. I will deploy it soon. I just need to make sure that my namespace was already created. Otherwise, it will fail. So I think it still was not yet created. Just give me 1 second. Let's see. OK, so yes, it was. So 49 seconds ago. You can see now that the Crystal is also here. So the Crystal team was onboarded to all my clusters. OK, so now let me commit this final change, which is called add Crystal app. And let me commit it. And I have the Argo CD UI open here. So I have the app of apps, I have the front end, I have the Node.js, and now you can see that the Crystal, as a result of my commit, the Crystal started to onboard as well. And this is the UI of the application. So I couldn't show, I wanted to show it to you before I added it, so, but you can believe me that there was only hello from backend and frontend, and now we also have hello from Crystal. So the Crystal application was onboarded for the Crystal team into the Crystal namespace. This is the application part. Now here, so we will not have time to wait for it, but you can believe me that in a couple of minutes there will be additional test environment created here. And as part of this test environment, all the add-ons, all the configuration, all the teams that we created will also be created there. So that's everything that we wanted to show you in this demo. So what we saw, actually, we saw several things. We saw how the platform team can manage multiple EKS clusters across different environments with consistent configuration, with all the tooling configured in really just a few lines of code. We saw how the teams allows us actually also a centralized place to manage the teams and access to those namespaces, and how this provides us a capability to have a multi-tenant clusters when each team is, on one hand, they're fully independent and have full ownership in terms of deploying their resources into this team, but still within the boundaries that the operation team provided them, such as resource quotas, for example, or some other boundaries. So that's it.
The environment just been added.
Sorry?
Go back.
Yeah, OK. Yeah, this is the proof. So we have now the test environment created here. And in several minutes, the cluster will be created with all the add-ons, and everything will be also installed there. So let me just go back to the presentation 1 second, just to show you a couple of final slides. So this solution, we created this as part of this EKS Blueprint Patterns repository. And we also published a blog. A blog has a much more detailed explanation on everything that we showed here. You can scan those QR codes in order to get access to the blog and to the application repository. And one last thing before we finish. If you want to continue and learn more about multi-cluster management, we have our other folks from AWS, Federica and Marco, presenting at 2:45 today, also on the topic of multi-cluster management, but more from the application side and from networking side of you. So you're welcome to get there.
I'll put, just in case.
So thanks, everyone.
Big congratulations on the successful demo. We have time for a few questions.
Yeah.
I would like to say that there's been lots of questions for you on Slido, so definitely check them out. So one that I'd like to ask you is, how do you enforce specific access control policies when using GitOps? For example, when you want to give a user access to only a single namespace.
This is, in Argo, you have app projects where you can define what specific target environments in Argo you can have access to. If I get the question right, like this is the way to go to do.
Yeah, maybe just to add on that.
Argo app projects. I think we also have it in the example.
Yeah, I decided not to show this part because we didn't have time. But yes, a project is like an additional let's say, a security measure that will force us, that will prohibit from the team to, create some other namespace, for example. So this is how it's done.
And then one last question is, how do you reduce code duplication when using GitOps?
I'm not sure.
I think, if I get the question right, it really depends on how you structure your manifest. So you can create an application collection of your, like an Argo CD application of your definition. You can have customization base folder and then customize it per environment. So it really depends on how you structure, how you deploy your application. But this is, if I get the question right, this is how you do it.
All right, give one last round of applause to Tsahi and Dima. Really well done.